So I did want to talk about how we find higher order derivatives implicitly. Um, remember that higher order derivatives are just us taking derivatives of derivatives and so on. So here we're being asked to find d squared y dx squared, which is a second derivative for 2x cubed minus 3y squared equals 8. In order to find a second derivative, I need the first derivative. So the first thing I have to do is find dy dx, my first derivative. So I'm noting x is my independent variable, so anything not x requires chain rule. So the derivative of 2x cubed would be 6x squared, don't need chain rule, minus derivative of 3y squared would be 6y, but that's not an x, so I need dy dx, equals derivative of 8, which is 0. I'm then going to go ahead and isolate my dy dx. So dy dx is equal to x squared over y. Well, now that I have this, I am going to use implicit differentiation and take the derivative of dy dx. Well, the derivative of dy dx is the second derivative. So d squared y dx squared. But now to do the derivative of x squared over y, I need to do the quotient rule. So I have bottom times the derivative of the top, and that's an x, which is still my independent variable, so I don't need chain rule there, minus the top times the derivative of the bottom, which would be 1, but y is not an x, so I need to dy dx, all over the bottom squared. Now I actually cannot stop there because I actually know what dy dx is. So I need to replace dy dx with what I know it is. So this means that my second derivative, d squared y dx squared, is equal to y times 2x minus x squared times x squared over y, all over y squared. And there is our second derivative. To see a second example of this, if I wanted to find the second derivative for the tangent of y equals x, again, I would start by finding dy dx. Noticing x is my independent variable, so anything that's not x requires chain rule. So the derivative of tangent y is secant squared y, but y is not an x, so I need to do times dy dx is equal to derivative of x, which is just 1. And that's my independent variable, so I don't need chain rule. Isolate my dy dx. And for the sake of what I'm doing, I'm going to remember that secant squared is 1 over cosine squared. And if I'm doing 1 over that, this is really just cosine squared y. Or to make it easier, since I know I'm going to be doing more with this, I'm going to write it so it's a little easier for me to square is outside, cosine of y is inside. So now I'm going to take the derivative of dy dx, so d squared y dx squared. For the derivative of cosine y squared, I need to do the derivative of the squaring first, times the derivative of cosine y, times the derivative of y. But I know what dy dx is already equal to, so d squared y dx squared is equal to 2 cosine of y times negative sine of y times cosine of y squared. And there is my second derivative.